Hello and welcome to Module 102 of the Linux Plus course. In this module, we're going to be talking about the installation of Linux and the management of packages. That includes a lot of other topics as well. We can see that this is 18% of the exam, so it's the second largest body of knowledge as far as content goes. And we have 5 different main topics for this module. We'll start off with designing the disk layout and some of the considerations for how that should be done for a particular type of system. Then we'll go into the boot manager options, which we touched upon a little bit in the last module. We were talking a little bit about grub. Shared libraries also need to be covered since that's part of the exam. And we'll see what that's about and why those are needed. Then we'll contrast and compare the different package management systems from Debian or from RPM and Yum. And then we'll compare the different package management systems for Debian, RPM, and Yum. And we'll see how those stack up against one another as far as usability and ease of use, really. All right, starting off with designing our disk layout. One of the things we need to think about is if we've got a physical disk, it has to be partitioned in order to create file systems. There are various different schools of thought for how partitioning should be done, so we'll talk about a little bit of that. Some of the reasons that a certain scheme over a different scheme is chosen is because of what the purpose of the system is. We want to also verify that, as we talked about a little bit in the last chapter, that there are certain details about our hardware that need to be checked to make sure we have full compatibility for the intended purpose of the system. And then our last topic will be to cover the logical volume manager. And you do need to have some understanding of what it's for and some of the basic commands. It's pretty easy to use, and I think you'll agree once you start practicing with these commands. So, as I was stating about the physical devices, once I create a partition or partitions, I need to think about file systems. A file system is a defined area on the hard drive which has certain capabilities and features in order to deal with storing, retrieving, and organizing data. File systems have lots of different characteristics depending on which ones you choose, and we'll see some of those comparisons a little bit later. But there are some interesting choices available depending on what your server is actually going to be doing. Now, the file system has to contain lots of different data structures to keep track of where all the folders are or the directories and all the individual files within those folders or directories. The basic details are here that we'd expect to find with any file or directory, which is when it was created, who owns it, which group owns it, how big is it, and of course, maybe most importantly, what are the permissions? So who's allowed to access this directory or file? Now, in the simplified manner of managing Linux, we can install everything in one single partition, which is what I've done for the virtual machine that I built for this course. This is obviously very convenient, but the downside is that in a true production environment, it could be dangerous. It might not be something that you want to do. The main reasons are that if root or the boot partition become full, which can happen under various circumstances, if that happens, then the system may not be allowed to boot. Or if it happens while the system is up and running, you may have problems with stability. It may crash, and now you've got to go into some recovery procedures to take care of the problem. So the way to get around this is to separate certain file systems into their own partition. Specifically, the home partition is a good choice for this, or user, possibly even var. And the main advantage is that I can create a file system for all my home directories of all my users. This keeps their data separate and isolated in case of somebody doing something that uses up a lot of space. They don't have any way to fill up the boot partition or the root partition by filling up their home directory. And that's what we're trying to avoid. So of course there is more administrative overhead in dealing with multiple file systems on a disk, multiple partitions. But as you'll see in later sections of this course, it's not really all that hard. It just takes a little bit of practice to get familiar with the commands and the concepts. Usually in a production system that you're trying to maximize performance, we typically have more than one disk. There might be several disks involved in the operating system and its required file systems. This is done for performance reasons typically, where I want to have a dedicated partition for booting for the operating system, but then I might have other partitions on different disks in order to isolate them for protection reasons and also to maximize the possible performance that I might get. If I've got a system that's fighting over access to its own partitions, that churn will definitely have an impact on performance for a very busy system. We also have to consider the importance of swap space. Swap space is needed because physical memory is limited, of course. Disk storage is limited. But if my system has, let's say, 16 gigabytes of RAM, that might not be that much for a server, right? That's a typical amount for maybe a workstation these days. But if my system had that much memory and it was running out of space, it's getting busy, there's lots of users attaching to the system. Once memory becomes very full, we call that memory being under pressure, then the swap space may be activated. So we can think of this as a way to extend the physical memory into a special partition on the storage device itself. Now, once swapping happens, the system can continue to operate. It can say, okay, my memory is full, but I can write some of my data to disk. This means that the system will be allowed to keep operating, but the downside is that the performance will suffer. And we can see a few of the commands here for investigating these features. We can start off with make swap. I'll run the help command for that. And all we're doing here is, just as it says, trying to define a new partition that can be used for swap space. Sometimes you have to do this on the fly. Maybe you've got a system that's already configured with some swap, but maybe it's not large enough. And therefore, additional swap needs to be created. And if we look at the man page, we can get a little bit more detail. As I mentioned earlier, I always encourage everybody to start off with -- help or -h for help, and then go to the manual page to get more details. We can see we've got a few options here for specifying a label, specifying the size of the pages. And another good tip when you're looking at man pages is to use the / key, because this is the man function utilizes VI style editing. So if I type /, this means I'm going to be searching for something. And I can just search for the word exam or example. All right, this one doesn't have any examples, but many man pages do have examples, and that gives you a little bit of extra information for using that tool. Once my swap space has been created, I can use swap on. And if I run, let me pipe this to more so we can see it all. Here I'm telling my operating system I've got a partition that I've created for swap, and now I want to enable it. So I run the swap on command. I specify the path to that file. Let's see if I have any examples here. Nope, that's fine. Not every man page has examples, as we can see, but we can also see that it's fairly simple. I tell it that I want to turn on this swap. I specify the device file, so /dev/sdb1 or something of that nature, whatever the partition is. Once I've done that, then the swap becomes available, becomes enabled. There's a separate command to enable and disable, of course. Just because I add it to the system doesn't mean it's ready to use. And then conversely, I can also disable swap and remove it from the configuration. And that might be needed because you've decided to add more physical memory, and now you don't need swap space or as much swap space. Just remember, swap is slower, but keeps the system running so that it can stay operational long enough for the required maintenance to be done. Now, when you're going through the install process, you have many options to choose from as far as what type of server you'd like to build. We start off with a minimal install, which is just what it sounds like. No GUI, very basic services. This is the smallest footprint, if you will. But other times, maybe you've got more specific ideas in mind. If I want to build an infrastructure server, I might decide I'm going to be adding a LDAP or DHCP or DNS, some of the basic services that I would find in a typical infrastructure. I can define those when I build the server and allow me to pre-build many of these capabilities instead of having to add them later. File and printing server, web server, these are obvious choices as well. I can also define my Linux server as a virtualization host, which is pretty interesting to have the hypervisor running on Linux. I typically use hypervisors on Windows like VMware Workstation, but you've got these options in a production environment if you want to use a Linux virtualization host. Then we have the server with GUI, which is what I built for the course. This installs a window manager and gives you the options to choose other window managers as well. The development and creative workstation includes lots of different tools, graphics tools, audio tools, software development tools. So when I select one of these items in the interface, on the right side of the interface, it'll show me all the different sub options that I have available. So if I was running my server with a GUI, I could have different things here like Java support, load balancer support, high availability if I'm building a cluster or something similar to that. So there's lots of different ways to make the initial installation much easier to deal with for these different capabilities. Now we can think about making sure that our system is able to utilize the hardware that it's being installed upon. The master boot record, the MBR, everyone probably has some awareness of this, but this is the first sector on the disk. So when I turn a system on, the MBR is the first thing that's read. And once that master boot record is read into memory, it knows where the partitions are to start the loading of the operating system. Linux defines primary partitions and extended partitions. This is somewhat similar to the way that Windows works, as far as having some limits on the basic partitions that you can create. And then, of course, depending on what size disks you are using and whether or not you want to use the GUID partition table scheme or GPT, then we can expand from these basic beginning settings. Anyway, so for a more traditional approach, primary partitions, I just have 4 options there and a relatively low limit on the size of the disk. This is mainly due to the fact that these standards were created when systems were mostly 32-bit architectures. Then there are extended partitions that can be created. So 3 more of those, 5, 6, and 7. And this was done when primary partitions were not considered to be sufficient. And primary means that the partitions are defined for things like booting for the operating system and for more of the core pieces of the OS, whereas the extended partitions might be for other areas like /opt or user directory, home directories, and those kinds of things. If I want to use large disks, then I'm probably going to the GPT scheme, because now I can use a huge disk, 8 zettabytes. And because I have 128 partitions possible, I don't have to deal with extended and primary differences. I can just create the disk using this scheme and have the ability to grow and expand into quite a large space. So some of the built-in or features you can add, to Linux is the volume manager. Logical volume manager is very easy to use, and I can demonstrate some of these commands here in just a moment. What I've done is added an additional virtual hard disk to my virtual machine. And I'll show you how that's done as well, since most of you are probably going to be using a Linux virtual machine for this course. Anyway, once I've got a disk, in this case a /dev/sdb SCSI disk B. SCSI disk A is already created by default when I built the system. So now when I create a new one, it gives the next letter in the sequence, which is B. So I have to run the pvcreate command to initialize this physical volume to be used inside of a volume group. Once I do that, I can use pvdisplay to see my physical volume that I just created, make sure it looks correct. Then I can create a new volume group, or I can add the physical volume to an existing volume group. I can also display that volume group by using vgdisplay to see any volume groups that are configured. And lastly, I use the lvcreate, logical volume creation, and lvdisplay commands to see what I've actually built. So let's go ahead and have a look at this. First, I'm going to run a command that we looked at in the last module. I'm going to list my block devices, lsblk. And you'll notice that SDB shows up. I created this as a 1 GB disk, and I'll show how this is done. It's very simple with a virtual machine. All I have to do is right-click on my settings. This is VMware Workstation for those that aren't familiar. But if you're using Hyper-V or VirtualBox, you'll figure out how to add hardware. So I go to my settings, and you'll see I have 2 disks. I could add a 3rd disk, which I'll demonstrate here. So I'll click Add. I want to select a hard disk by default. That's good. I'll keep it as a SCSI disk. Create a new virtual disk, and I'll just use another 1 GB. I usually prefer to store my disks as a single file versus the default of multiple files. You can read the description as to why that would be, but single files are just a little bit easier to deal with. And now by default it gives me a name. The previous disk I added was the same name, but it was a 0 here instead of a 1. Now since I've added a 3rd disk, I get the next number in the sequence, which is 1. So go ahead and click that, click OK. And the fastest way for that disk to be usable is to just do a quick reboot. So I'm going to do a shutdown -R for reboot, and I'll say I want to do it now. And this should only take a few moments. Luckily, virtual machines boot very quickly. There are other ways to initialize that new storage, but a reboot is the easiest thing to deal with for right now. So we're going to go ahead and take the simple approach. And I'll get myself logged in. And open a new command shell. I like to make it full screen. And I'm going to enlarge the font a little bit. Remember, the shortcut for this is Control-Shift+. You could change this in the settings to give you a default font size that's larger. And I'll show you how to do that here in just a moment. Let's do that real quick. So I'm going to go to my profile preferences for the shell, and I can create a name for the profile. I usually don't do that. For colors, I like green on black. Personally, that's a favorite because it reminds me of my early days using Unix and Linux, and it's just kind of easy on the eyes as well. But you can change different aspects of the colors. I can define the scroll buffer. 1,000 lines is pretty good. There's also some compatibility settings for different applications. But going back to the general window here, I can define what the starting size is. 80 by 24 is pretty typical. And I can pick my custom font. So I'm going to change this to a 14-point font. And I think that added 14 on top of what I already did before, so I'm going to shrink it back down just a touch. And you shrink the back down from the keyboard anyway by doing Control minus. Control Shift plus to enlarge the font, Control minus to reduce it. Another handy shortcut, as long as we're talking about the show, is Control Shift T, which opens up another tab. And now you see I can select between those two tabs. This is very handy when you're doing multiple things and you don't want to keep on switching windows. I can just create multiple tabs, just like a web browser. It's very similar. Anyway, LSBLK, now it shows me my new disk, SDC. So I'm going to run the pv create command on dev SDB and dev SDC. You notice I can give multiple arguments. That's pretty handy. And I can run pv display to see those new disks. There's dev SDB, tells me it's 1 GB volume. There's my device file. Also has a unique identifier, the UUID for this physical volume. And then I have SDC, another 1 gig volume. Now all I've done is just change the partition table a little bit to initialize the disk. Now I can create a new volume group. So I'll run the VG create command. And I'm going to call this my VG. And I'm going to add dev SDB and dev SDC. Very simple, straightforward. Again, use the dash help or the man page for more details. I can now run VG display. Now, if I run this without any arguments, it's going to display both volume groups. My initial volume group, which was created during install, CentOS, and then the new one, my VG, tells me that there are 2 metadata areas, which is my 2 disks. I've got 2 current physical volumes. That's what cur PV stands for. And both of those physical volumes are active. So my volume group overall size is just under 2 GB. You lose a little bit of space due to the overhead of managing the data structures. And I have 510 physical extents. You can allocate space using extents if you like, or you can just specify size. For the purposes of the exam, you don't need to worry too much about extents, but it is another option to consider. All right, so my volume group is now created, and what I want to do next is to create a logical volume. So I can specify the LV create command. Let's run help on this. See, it's got a lot of options. So I can specify the size by extents. I can even specify stripes if I'm creating a logical volume that's going to span more than one physical disk, which I could do because now I have two hard disks in this volume group. You can specify percentages for your extents. So I either specify the size in megabytes or by an extent, and an extent could be it's a configurable unit of data, 1 megabyte, 4 megabytes, and so on. Or I can do it as a percentage. And you could do things like grow and shrink logical volumes as in addition to just creating them and creating volume groups. So I'm going to do a man page for LV create. And I'm going to search for examples. Here we have many examples. So a very simple one is just to create a logical volume with a certain size and the volume group being specified. So I'm going to do something kind of similar to this. I will run LV create -L 100 megabytes / dev my VG. Now by default it just creates lval 0. I could have given it a label if I wanted. And now I can look at this. I can say let me display this logical volume by running lv display /dev /my VG lval 0. And there it is. It's 100 megabytes. used 25 logical extents, which means that my 4 megabyte extent, which is kind of a usual default, that's currently how many extents I'm using to create a 100 meg segment. So it's very simple. And as we'll see later, once we create a logical volume, then we can put a file system on it. This logical volume, it sits on the, let's look at the, hold on. We're going to look at LV display again. And what I can do with this is I can see where my logical volumes exist on all of the disks in the volume group. But as it says, we just need basic knowledge of logical volume manager. So PV create to initialize the device and then display them to make sure you've done it correctly. I can create volume groups using those physical devices and then create logical volumes. Logical volumes can be designated for a single disk, or they can be striped across multiple disks. And you might do that for performance or redundancy reasons. All right, so these are some of the commands that we looked at in this section. As far as file systems go, some of the ones that are created by default, we can run the df command. We'll see more of this later, but if I run df for disk usage, I can use the -h option for human readable, which we talked about in a previous section. But you'll notice that I've got my root file system. I also have boot, so that's on SCSI device A, partition 1. And then I still have my CD-ROM mounted. If I wanted to create new file systems on other logical volumes that I've created, which we'll do later, then they would also show up here. All right, so that's the end of the hard disk layout. We'll see you in the next section, which is installing a boot manager. Thank you.